For years, the dominant idea in artificial intelligence has been simple. Make models bigger, deeper, and more complex, and intelligence will emerge. Add more layers, more parameters, more data, and supposedly, better reasoning will follow. But a recent study published by Google challenges this assumption at its core, and what it proposes could fundamentally change the future of AI. Most modern AI systems, especially deep learning models, rely on stacking layers upon layers of computation. This approach has worked remarkably well, powering language models, image recognition systems, and recommendation engines. However, it also comes with major limitations: massive energy costs, brittle reasoning, and a lack of true adaptability. These systems don't really learn continuously. They're trained once, frozen, and then deployed. Google's research asks a critical question: what if scaling depth isn't the real path to intelligence? What if we've been mistaking size for understanding? The study introduces a concept known as nested learning. Instead of relying on a single, monolithic learning process, nested learning uses multiple learning systems operating at different timescales simultaneously. Some components adapt quickly, reacting to immediate patterns, while others learn slowly, capturing long-term structure and meaning. This mirrors how the human brain works, where short-term learning, habit formation, and long-term memory all coexist and interact. In traditional deep networks, everything learns at roughly the same pace. In contrast, nested learning allows different parts of the system to evolve independently, creating a hierarchy of learning processes inside the model itself. This makes the system more flexible, more stable, and potentially far more efficient. Google tested this idea through a model known as HOPE, which demonstrated improved performance on several reasoning and prediction tasks compared to standard deep learning approaches. But the most important result wasn't just better benchmarks, it was the way the model learned. Instead of needing constant retraining from scratch, it could adapt incrementally, integrating new information without overriding what it already knew. Why does this matter? Because one of the biggest problems in AI today is that models don't truly understand or evolve. They don't accumulate knowledge the way humans do. They don't build on experience, they just optimize patterns. Nested learning suggests a path toward AI systems that are not just trained, but developed over time. This approach could also drastically reduce computational costs. Rather than endlessly scaling models to absurd sizes, we could design systems that learn smarter, not bigger. That has implications not just for performance, but for sustainability, accessibility, and who gets to build powerful AI in the first place. Of course, this isn't a magic solution. The research is still early, and nested learning needs to be tested across more real-world applications. But it represents a shift in mindset, away from brute force scaling and toward architectures inspired by biological intelligence. In short, Google's study suggests that the future of AI may not lie in deeper networks, but in richer learning dynamics. Not more layers, but more ways to learn. If this direction proves successful, it could mark the beginning of a new era in artificial intelligence, one where machines don't just process data, but grow with experience. And if that happens, the way we think about intelligence, artificial or otherwise, may never be the same.